In the last segment, we talked about what happens when you have three areas of electron density. And the model I used for you at home is you in the middle, left and right hand, and your toes, and we're going to call those YMCA arms. What we saw was that when we have three areas of electron density, the shape of our electrons will form trigonal planar. If we have an actual atom bound in three places, we have trigonal planar molecular shape. When we have a lone pair, we have something that is bent. Now we're going to move on to four areas of electron density. And if we go back to our 360-degree circle, and I don't ever ask people to do this because this is not possible, but let's pretend you're in the middle. You have your left and your right hand, and you've got one set of toes, left foot and right foot. Okay, now obviously you cannot do that, but just go along with the visual. What you would have in this plane is 90, 90, 90, and 90. Okay, so you in the middle, left and right arms, left and right toes. And then we're going to turn you into the hula hoop plane and pretend you're looking straight down. You would still have your left and your right hand this way and your toes pointing straight up and down. Okay, so now what we have is 90 degrees in this plane and 180 degrees in this plane. And it is at this point in time that we can do better. We can do better than this. Okay, and what we end up with is, I'll draw it first. Okay, so here's you. I'm just going to say A, B, C, D. Okay, so now the way I'm drawing this is showing that this C, or whatever is going to be attached here, or these electrons here, are going to be pointing towards you, and this is going to be pointing away from you. And so this shape is now what we call a tetrahedron. So I'm going to hold it just as I've drawn it. Okay, in my right hand, these two pairs are in the same plane, just as I've drawn it. And then this one is pointing towards you, like I've drawn it. This one's pointing away from you, like I've drawn it. Okay, so now this is called a tetrahedron. And now we are no longer flat. We are no longer flat. 2 and 3 is flat plane. When we get to 4 areas of electron density, we end up with something that has 3 dimension. So I'm going to rotate this around, and you tell me if it, well, you can't tell me in a video, but ask yourself, is this the same or different? Okay, so I'm going to rotate this around. Same, 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 same. So what this is showing is that I no longer have anything that's flat, and that the angles here are all the same. And that angle is 109.5 in all directions. And this is your tetrahedron, or tetrahedral. Okay, 4 is a prefix for tetra. Okay, and so we're going to have the same thing. We're going to have our electron geometry. When we have 4 atoms bound, is still going to give us something that is tetrahedral. When we have lone pairs, we have to subtract this out in our mind. Okay, so let's say we have 1, 2, 3 atoms bound, and then we have a lone pair on the central atom. Well, remember that the lone pair does not take up space. So I'm going to subtract that out in my mind, and I end up with this. Now this is a little hard to see, but if I turn it this way and pretend that I have it on a table down here, what you can see is that this is no longer flat. This is what we call a pyramid, or trigonal pyramid, because we have 1, 2, 3 legs. 4 areas of electron density, 1 lone pair will give us this structure. If I have 2 lone pairs, okay, so now here's my 1, 2, 3, 4, And instead of one lone pair, I have two. Well, I still have my tetrahedron electron geometry. 1, 2, 3, 4. It is still 4 areas of electron density, but 2 of them are lone pairs. So I'm going to subtract those out, and I get this structure, which is bent. Okay, this is bent. So some classic examples of that are NH4 plus, 1, 2, 3, 4 areas of electron density. The electron geometry will be tetrahedral. Molecular geometry will also be tetrahedral. There's no lone pairs. However, if I have pH3, I've got a lone pair on my central atom. Okay? So what I would have is tetrahedral for the electron geometry, but my lone pair, you have to subtract it out. It doesn't take up space. So it's still going to be tetra. That's what the electrons are going to do, but we're going to have a trigonal pyramid. Okay, a trigonal pyramid. Okay, and then last example, we can end up with molecules that have multiple central atoms, like this one. Carbon, this is tetrahedral. Carbon, tetrahedral. 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. These are tetrahedral, but let's take a look at the oxygen. The oxygen here has 1, 2, 3, 4 areas of electron density, so we're going to call that tetrahedral. But there are 2 lone pairs. Okay, so we're going to pretend that okay, so here's a model of this, and we're going to pretend that this blue piece is all this carbon stuff. Okay, so we've got all this carbon stuff, the oxygen, the hydrogen, and 2 lone pairs. So you can see that the electrons are still forming a tetrahedron. However, when we subtract out the lone pairs, the shape, and this is all this carbon stuff over here, so we're just looking right here at the oxygen, is still bent. Okay? Bent. Okay, so on this one, again, go back to your 6 pages and find all the structures that have 4 areas of electron density. Okay, 4 areas of electron density. Describe their electron shape and then their molecular shape. And as you're doing this, if you can actually draw them, because remember that our goal here is to find a net dipole. And so we've got 2 more. We have 5 areas and 6 areas, and then we will be done with this, and then we will go looking for our net dipole.